Imagine uncovering the universe's most dazzling secret. What if the brightest fast radio burst ever detected could unlock long-standing cosmic mysteries? And this is the part most people miss. Understanding these fleeting signals might finally reveal what really powers them. Recently, astronomers identified the most luminous fast radio burst, FRB, to date, originating from a nearby galaxy. This tiny flash of radio waves, lasting just about a millisecond, might hold clues to one of astronomy's biggest puzzles. FRBs were first discovered in 2007, but their origins have remained an enigma. These bursts come from beyond our galaxy, and scientists have been diligently tracing them back to their sources, hoping to uncover what catapults such enormous amounts of energy across space in such a brief moment. The newly detected FRB, called RBFLOAT, short for Radio Brightest Flash of All Time, was observed on March 16th. Its precise origin was pinpointed to a galaxy named NGC 4141, positioned approximately 130 million light-years from Earth. This discovery was made possible thanks to the Canadian Hydrogen Intensity Mapping Experiment, better known as CHIME, paired with its new array of smaller telescopes called outriggers, whose capabilities for sharper localization were highlighted in a recent publication in the astrophysical journal Letters. Amanda Cook, the lead researcher from McGill University, shared her excitement. With the CHIME outriggers, we're finally catching these swift cosmic signals in real time, narrowing down their exact locations not just to entire galaxies, but often to specific stellar neighborhoods. After detecting the burst, scientists employed NASA's James Webb Space Telescope to observe the site in infrared light. These follow-up observations have bolstered a leading theory that magnetars, ultra-magnetized remnants of dead stars, could be the culprits behind FRBs. Another related study, also published this week, details Webb's findings, adding weight to this magnetar hypothesis. Peter Blanchard from Harvard explained the significance. This was a unique chance to quickly point Webb's infrared sensitivity directly at the FRB location, and what we saw was intriguing. Faint infrared emission very close to where the radio burst originated. This could actually be the first stellar object in another galaxy convincingly linked to an FRB. These breakthroughs not only help pinpoint the origins of these mysterious bursts, but may also clarify whether all FRBs follow a repeating rhythm akin to a cosmic heartbeat, or if some are one-off events with no repeats. One big question remains: are they all fundamentally similar, or do different types exist? CHIME, based in British Columbia, has been a powerhouse for discovering and cataloging thousands of FRBs since its deployment. Recently, enhancements called outriggers, set up across North America, have improved its ability to locate these bursts with stunning precision. Compared to earlier, broader localizations, this new setup can identify a burst's source region as small as a cluster of stars. Imagine distinguishing a quarter from over 60 miles away, says Cook. Before this, pinpointing an FRB's exact location was like hearing someone's voice on the phone but not knowing what city they're calling from. Now, we're not just hearing the voice, but knowing the street, house, and room. In follow-up observations with telescopes in Arizona and Hawaii, researchers found that RBFLOAT originated from a spiral arm of its host galaxy, a region rich in star formation, yet notably outside the most active stellar nurseries. Interestingly, the burst's location outside a star-forming core suggests that the magnetar either was kicked away from birth or was born at a different spot within the galaxy. Using Webb, the team searched for infrared signals coinciding with the FRB origin. They discovered a faint object, labeled NIR1, which could be a massive star or a red giant, stars nearing the end of their life cycles. These are unlikely the direct sources of the burst, but an unseen companion, like a neutron star, may be siphoning material from this star, potentially triggering a radio flash. Alternatively, the infrared light could be a reflection or reprocessing of a magnetar flare. Blanchard emphasizes that whether NIR1 is directly involved or just nearby, valuable insights are gained. If the star isn't part of a binary system, the data suggests that an isolated magnetar might be responsible for the burst. Interestingly, this particular FRB, RBFLOAT, was singular. No repeats were detected despite hundreds of hours of follow-up. This makes it the first non-repeating FRB to be localized so precisely. Sunil Simha pointed out that mapping this burst's environment opens new avenues. We can now ask whether other non-repeating FRBs share this trait, or if RBFLOAT truly stands apart as an anomaly. So, it seems we're at the dawn of understanding these cosmic blips. Whether all FRBs are just fleeting bangs or there's more to their rhythm, and whether they're all linked to magnetars or different objects, remains a provocative question. What do you think? Are we close to solving the FRB puzzle, or is the universe still holding its secrets tight? Share your thoughts. This debate is just getting started.